Hello students, welcome. This is Mr. AMARJYOTI NATH, mentor of physics for IIT JEE and NEET. Today just we are going to discuss a small topic but very important for that one JEE as well as NEET, that is resistors in series and parallel. Okay, we will discuss some numericals also, very beautiful numericals. Okay, and okay, let's discuss first resistors in series. Okay, so how can you say that two resistors are in series? Okay, what is resistance? Resistance is nothing but opposition to the flow of electric current. Okay, so we are not going to discuss in details about that. Okay, it is already understood. Just we are going to discuss that combination of resistance part only. Okay, that is resistors in series, resistors in parallel. First we are going to discuss resistors in series. Well, say we have one resistance, that is R1, okay, and that is R2. Well, when we can say that these two resistors are in series, the only and only definition is if the charge flowing through both the resistors are same. That is very important. Charge same. Okay, say q coulomb charge is going through this resistor, so that same q coulomb charge will be passing, because no other ways are there, no? So that q coulomb charge will be passing through this resistor also. Then we can say that they are in series. Okay, you can say that current also same. Okay, better word we will use same. Okay, not equal. The good best word will be same. Say we have connected it with a battery of potential difference, say V volt. Well, so as it is positive electrode, so we can say that positive charge will flow in this direction, will constitute which constitutes current. Okay, so the current flowing through this first resistance must be flowing through the second resistance also. Okay, same current, so that is why we call it is in series. Okay, so what is the definition of series resistance? Two resistors are said to be in series if the same charges flow through both the resistors. Okay, that is very important. Now you see, when say current I is established, okay, and the potential drop at this resistor is say V1. Okay, at this resistor say it is V2, but total potential is V only, so we can write that V equal to what? V1 plus V2, because total potential change in a closed loop, it must be 0 only. Total potential change, from the Kirchhoff's law we understood these things. Well, so that V1 can be written as current into resistance. Okay, current into resistance, and V2 also can be written as current into resistance. Well, and net voltage can be written as net current, because net current means current passing through the battery also I only, so net current into net equivalent resistance. Okay, so II will get cancelled, so R equal to what? R equal to R1 plus R2. Okay, if we have three resistance, so it will be what? R1 plus R2 plus R3 and so on. Okay, so that way it will keep on increasing. So this is something about resistors in series. Okay, and one more thing, we understand that when few resistors are in series, their net resistance is always greater than the greatest. Okay, say out of this R1 and R2, say if R2 is greater than R1, okay, so it means net resistance will be even greater than R2 also, because there is just algebraic sum only, no? That is why. Now come to that parallel combinations. Okay, just I am coming to the numerical part only. Okay, as fast as possible. The resistors in parallel, the basic definition is what? Say this is one resistance R1 and this is another resistance, say R2. These two resistors are said to be parallel only when the same potential difference applied across the both the resistance. Okay, in the previous case we got the same charge, but here potential change. Okay, potential difference same. Say the potential difference between these 2 points is say V volt, means same V volt is experienced by this resistor also as well as this resistor also. That is very important point. Okay, so what is the basic definition of that one parallel combination? Means two resistors are said to be in parallel if they have the same if they have the same potential difference. Okay, that is very important. Well, say I current is drawn from the battery. Okay, so in this, say I1 is flowing, and in this, say that is I2 and that is I1. Okay, so from Kirchhoff's law we can understand that net current I equal to what? I1 plus I2 only. Well, so that I1 can be written as potential difference divided by resistance. It means V by R1, and I2 can be written as potential difference by resistance, means V by R2, and net current can be written as net potential difference by NATH resistance. Okay, so V will get cancelled, so it means 1 by R, it can be written as 1 by R1 plus 1 by R2. Okay, reciprocally they got added, that is very important. And one more thing we should understand, if as in parallel combination actually the net resistance is lower than the least. Okay, R1 will be less than net resistance will be less than R1 if R1 is even less than R2 also. Okay, so out of R1 and R2, R1 is less, so it means net resistance will be even that less than R1 also. Okay, well, I think we are ready to hit some problems. Okay, say first problem we are going to take. Okay, from that two definitions only we are going to solve it, all these problems. Okay, say this is we need to find the equivalent resistance of the network shown in the figure between the points A and B. Okay, between point A and B we need to find out the resistance. We have seen actually three resistance. They seem to be in series, but actually let us see whether they follow the definition or not. See, we need to find out the resistance between A and B. What does it mean? If you assume that we connect a battery between A and B, okay, we that supply a potential difference between A and B, so charge will flow either in this direction or in opposite direction, no problem. So what is the total opposition to the flow of charge? That is the main important thing. Well, so first of all you can see that here current will be bifurcated. Okay, at this point only. Okay, so we are not sure the current flowing through this resistance are same, maybe equal, but remember it should be same, then only they are series. Okay, but let me check it whether they are parallel or not, because whether they are series or not it is not sure now, no? So let us check it whether they are parallel or not. Okay, say the potential difference across the battery is V volt. Okay, assume that, and this point's potential is say A, this point's potential is say B. It means A minus B equal to V. Okay, so as it is a metallic wire only, so every point will have the same potential. Okay, so this point's potential also A, and also this is a metallic wire only, so this point's potential also will be A only. Okay, and this is longer electrode, this is shorter electrode, so means potential of A is greater than potential of B. I am assuming just like that, nothing else. So exactly that way this point's potential will be B, so this point also B. It means ultimately we can see that this point's potential also B only. Now you can see this resistor is under the potential difference A minus B, and this resistance also under the potential difference A minus B, same A minus B, and this resistor also under the potential difference same A minus B only. Okay, A minus B. Okay, so it means actually they are like that. If this is the A point, if this is the B point, it means this resistance is under A and B. Okay, and this resistance also under A and B only. Well, and this resistance is also under same A and B. Okay, all the three resistors are actually parallel. Okay, so if you want to find out the net resistance between A and B, so what I can write, 1 by R equivalent equal to 1 by R plus 1 by R plus 1 by R. Okay, so it means 1 by R equivalent, say R equivalent is R dash, it is equal to 3 by R. So R dash equal to what? R by 3 only. Okay, though they seem to be series, but actually they are found to be parallel only. Okay, even in this resistor in which direction current will flow, that can also be calculated, because on a resistor always current flows from high potential to low potential. Na? So here A potential is greater, so it means here also A potential will be greater, B potential will be lower. So current in this resistance will be flowing in this direction. Okay, in this resistor current will be flowing in this direction, and in this resistor current will be flowing in this direction. Okay, that way you can check this also, no problem. Well, so let us hit another one. Okay, so this problem, find the equivalent resistance of the network shown in the figure between the point A and B. Okay, so we need to find out the resistance between A and B. Okay, the other parts, the periphery is a metallic wire. Okay, that is we should understand these things. So resistance between A and B is what? If I connect between A and B a cell, okay, so the current will flow. Okay, so what is the net opposition to the flow of current? That is the resistance, or that is the equivalent resistance definition. Well, say this point's potential again. Say this is A. Okay, this point's potential is B. So VA minus VB is nothing but voltage of the battery. Okay. So as this point's potential is A, so automatically this point's potential also will be A only. Well, now this point's potential is B, so this point's potential also will be B, and as this is a metallic wire only, so this point's potential also will be B, this point's potential also will be B, this point's potential also will be B, this point's potential also will be B only. Okay, we have altogether 4 resistors. Well, and we need to find out the net resistance between A and B. Okay, say this is the point A, say this is the point B. Well, so first of all, think of this resistance. It is under the potential difference A and B only. So let me draw it. Okay, I have drawn it. Well, so now think of this resistance. This is also under the potential difference A and B only. Well, so let me draw it. Well, that is also R. Let me draw this resistance. That is also under the potential difference A and B only. Okay, so let me draw it. I have drawn it. And finally this resistance is also under the potential difference A and B only. Okay, so it is clearly visible that all the resistors are in actually parallel. No? We need to find out the resistance between A and B only. No? So what is the opposition to the current when current enters at A and leaves B, or vice versa? Okay, no problem. So 1 by R equivalent is nothing but 1 by R, 1 by R, 1 upon R, and 1 upon R. Okay, so it is nothing but 4 upon R. So that is 1 by R dash. So R dash equal to what? R upon 4. So that is the net equivalent resistance. Okay, these are some that way we can make that figure very complicated also. With time we are going to discuss all these things. Think of this problem again. Okay, find the equivalent resistance between the point A and B. Okay, we are going to just with the definition only. Okay, today's discussion will be wholly dependent upon that definition of series and parallel. Series and parallel. Okay, so find the equivalent resistance between A and B in the following circuit. Okay, so this is A point, this is B point. Okay, so what is the net resistance? Well, same thing. Say current enters through the point A and leaves through the point B. So what is the net opposition? Okay, that is the point. Say this point's potential is A, so automatically this point's potential also will be A only. Why? Because it is a metallic wire, and there will be metallic wire means we are assuming that no resistance. Okay, as no resistance, so no voltage will be dropped there. Okay, so this point's potential is A only. Now you say this is the potential of this point is B, so automatically this point's potential also will be B only. So let me draw that equivalent circuit. Okay, now you see this is the point A, this is the point B. We need to find out the resistance between A and B. See this resistance, think of this resistance. It is under the potential difference A and B only. Let me draw it. Well, I have drawn. Exactly that way this resistance, it is also under the potential difference A and B only. A and B only. So let me draw that. Okay, I have drawn 2 resistance till now. No? Now you see, think of this resistance. Whatever charge passing through this resistance must pass through this resistance also. Well, this is a disjoint branch. Okay, they are not connected. So but the charge flowing through this resistance must go through this. So it means this and this are in series. So as R and R are in series, the net resistance in this line will be 2R only. We have we know the definition of series. Okay, 2R, but remember this 2R under the potential difference A and B only. So that will be 2R. Okay, under the potential difference A and B. Exactly that way you can see this charge flowing through this R will be passing over this, passing through this R also. It means this R and this R are in again series. Okay, so we can write that 2R and this 2R under the potential difference A and B only. Okay, so now the picture is clear. What is the resistance between A and B we need to find out? Well, so we can easily find out 1 by R dash equal to what? 1 by 2R plus 1 by R plus 1 by R plus 1 by 2R. Well, so if I take the LCM 2R, so 1 plus 2 plus 2 plus 1. Okay, so it means 2 to 4 5 6 6 2R. Okay, that is 3. So R dash equal to what? R dash equal to R by 3. So I hope you are just step by step you understood all these things. Okay, if you are a new learner, then okay, automatically you will be just following all these things, and you have to practice lot of problem of this type, no problem. Okay, well, so let us try this problem also. What is the resistance between that P and Q? Okay, we need to find out. In the circuit shown in the figure, R equal to 55. Okay, value will be put later, no problem. The equivalent resistance between the points P and Q I need. Okay, so if this point's potential is P, so this point's potential also will be P, this point's potential also will be P, this point's potential also will be P, but this point's potential will not be P because resistance is there. As current flows, so voltage will be dropped, so it means this point's potential will be something else. Say this point's potential is Q, so this point's also potential will be Q, this point's also Q, this point's and this point's also will be Q only. Okay, say this point is R. Well, we should take some other symbol because R is already taken. So this point is S, so automatically this point also will be S only. Okay, but remember we need to find out the resistance between P and Q only. Okay, that is P, that is Q. Okay, so step by step we can draw all these things. Say in between we get a point S. Okay, so we will do all these things, no problem, step by step. So this resistance, think it is under the potential difference P and Q. So I have drawn it. Well, then you think of one more resistance P and Q, na? So no more resistance under P and Q, na? So this resistance is under Q and S. Okay, Q and S. So Q and S, I have drawn it. Well, all our values are R only, so no problem. And this resistance is under P and S. Okay, P and S. Well, this resistance under SQ. So it means these two will be parallel. Okay, and this resistance under PS. Well, PS, and finally one more resistance left, that is SQ. Well, so that is also SQ. Well, I have included all the resistors 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. Well, now I think picture is clear. Okay, what is the resistance between P and Q? Again you can redraw it, no problem. That is P, this part is R. Okay, and this part is R by 2 only, R and R parallel. Okay, so this part is R by 2 and this part is R by 3. Again R by 2 and R by 3, these two are in series. Okay, so what can I do here? That is R. Well, so if I take the LCM, that is R, so it will be 5 R by 6. Okay, R by 2 plus R by 3 only, nothing else. R by 2 plus R by 3 only. Okay, that is 6, so it is 5. Okay, well, so now the NATH resistance we need to find between P and Q. Okay, so 1 by R dash equal to 1 by R plus 1 by 5 R by 6. Okay, so if we take the LCM, this is 5R, so that 5 and 6 11, na? So it means 1 by R dash equal to 11 by 5R, so R dash equal to what? 5R by 11. Okay, but according to the question R is 55, so it means R dash equal to 5 into 55 by 11. So if you cancel it now, 55 and 11, na? So it will be 5 times, so it means R dash equal to what? 25 ohm. Well, so final answer is 25 ohm. Well, so this way we can discuss the problem. So basic theory is what? Basic theory is just series combination definition and parallel combination definition. Okay, and lastly you can discuss this also. Say this is the point A and this is the point B. I need to find out the resistance between A and B. Okay, so this point's potential is A, this point's potential is B. Say this point's potential is something C. So as it is a metallic wire, so automatically this point's potential also will be C only. Well, say this point's potential is D. So as it is a metallic wire, so this point's potential also will be D only. Well, and one more thing, the charge flowing through this R will be same as will be passing through this R also. It means this and this are in series. Okay, exactly that way. This and this are in series. This and this also will be in series. Well, so if I redraw the circuit, okay, if I redraw the circuit, say this point is A and this point is say B, we need to find out the resistance between A and B. So and in between we have a point C and D. Okay, we have points C and D. So from A to C, one R is there. Let me put it. Okay, from C to D, 2 R is there. Okay, 2 R is there. C to D, 2 R is there. Okay, 2 R. Then again C to D, 2 R. Okay, that is also 2 R. Well, then from C to D again 2 R. Well, these all are parallel only. These all are parallel. Then from D to B, 1 R is there. Okay, that is R. So this R and this combination and this all are in series. So if I redraw this figure again, say this is the point A, that is R and that is 2R by 3 only because all are parallel. Okay, and again this is R. Okay, so I need to find out the resistance between A and B only. So it is nothing but R plus R means 2R you can directly write, or 2R by 3. Okay, 2R plus 2R by 3. So altogether you can find 3 to the 6, so 8. So 8 by 3 R, that is the NATH resistance between A and B. Okay, so using a very small concept, series definition of series and definition of parallel, we could do all these beautiful problems. Okay, we can go even to the more depth of such problems. Okay, so you can that way you just keep on practicing. Okay, thank you, good luck.